Solubility of gases. Solubility of gases in liquids, right? So solubility of the gases in liquids is explained by, so we have the law, we called it as Henry's law. We use it as Henry's law, but we will understand it. So कैसे होता है देख लीजिए. Let us take one beaker लिया है मैंने. इस beaker में यहाँ तक we have filled with water. The water is filled. So this portion of it, this entire portion of it is filled with air or any gas, right? So liquids, when they are in contact with air or any gas, so the molecules which are close to the surface of the liquid are captured by the liquid into the liquid. So these gas particles will be captured into the liquid. So that's why the some portion of the air or gas gets dissolved in the water. So that's why any liquid which is in contact with air or atmosphere has got some air dissolved in it. Some air dissolved in it. So this air dissolved, whatever the air is dissolved is explained by a law called as Henry's law. Chala important amma, Henry's law. The amount of the gas dissolved in a liquid is directly proportional to इस गैस का जो भी प्रेशर होगा ना, इस प्रेशर के डायरेक्टली प्रोपोर्शनल होगा. सो ये प्रेशर के गैस के प्रोपोर्शनल होगा. फॉर एग्जांपल यू हैव द एयर हियर, इसका प्रेशर मैंने कुछ 10 atms रख दिया है. सो द अमाउंट ऑफ एयर डिजॉल्व्ड इन द वाटर विल बी हायर. इफ़ आई कीप इट लाइक 1.2 atms रखा है तो एटमॉस्फेयर से थोड़ा ज़्यादा एटमॉस्फेयर रख दिया है. सो द एयर डिजॉल्व्ड इन द वाटर विल बी लेसर. बेस्ट एग्जाम्पल फॉर दिस इज soda water. Do you know how soda water is being prepared? Right? Soda water contains what? Or any fizzy drink. You take any fizzy drink, so which contains, any fizzy drink contains the carbon dioxide dissolved in it. For example, if you take थम्स अप और स्प्राइट ले लेंगे, सो इस बॉटल के अंदर कैसे होगा? ये बॉटल ऐसा कुछ होगा. This bottle is being tightly capped. So when some liquid is placed in the bottle and carbon dioxide at high pressure is pumped into the bottle and it is sealed tightly. This is how the fizzy drinks are being manufactured. What happens if you get open it? इसको open करने से immediately क्या होगा? The carbon dioxide which is उनको ज़बरदस्ती से इसके अंदर घुसा दिया है तो ये वापस आना शुरू करेगा. दैट्स वाई द फिजी ड्रिंक्स गिव्स एफरवेंसेस व्हेन इट इज ओपन, राइट? सो इफ यू हीट द टेम्परेचर ऑफ इट, द फिजी ड्रिंक, द कार्बन डाइऑक्साइड कम्स आउट विद द फोर्स, राइट? सो दिस इज हाउ द gases dissolve in water. So this is explained by the Henry's law. Henry's law కూడా ఏం లేదు చూడండి. The amount of gas dissolved in a liquid is directly proportional to the partial pressure of the gas, right? So partial pressure of the gas, the amount of, I'll write here, the amount of gas dissolved in liquid is directly proportional to is directly proportional to the partial pressure of the gas. The partial pressure of gas. So this is what you call it as Henry's law. Of course, at constant temperature. Temperature constant rakke, if you increase the pressure, the amount of gas dissolved will be highest hoga. We'll take one example here. Why I have started here? Wait a minute. Right. So I'll take two containers here. This is one container. So this is another container. This is the third container. मैंने तीनों में वाटर फिल किया यहाँ तक. All three are filled with the waters. Water, water, water and water. तो इसको बंद कर दिया है अच्छा से. So all of them are closed tightly. And assume that इसमें the pressure is 1 atm. The air ఇక్కడ air ఉంది. So this is liquid and this is the air. So here you have got air. So this is air. So here it is kept at 2 atms. So this is of course liquid. Here the air is kept at 10 atms. Here the gas is kept at 10 atms. So where do you think the air is most dissolved in water? So you have three cases. A case లో water is deeply dissolved in the water. చెప్పండి అమ్మా, ఆన్సర్ చెప్పండి, ట్రై చేయండి. You have three beakers. I gave you the three different situations. In three different situations, the air is the atmosphere air is different. So here it is 1 atm, here it is 2 atms, here it is 10 atms. In which case the air is most dissolved in the water. చెప్పాలమ్మా, గట్లా మేలుకుంటుంటే ఎట్లా? అన్మ్యూట్ యువర్ సెల్ఫ్ అండ్ టాక్.
10 atm, sir.
Yes, third case లో ఎక్కువ డిజాల్వ్ అవుతుంది. So that is what the Henry's law is, right? Higher the pressure of the air, the amount of air dissolved in water is great. Lower the amount of pressure of air in contact with liquid, the solubility is low, isn't it? So that's what the Henry's law is. I'll write the Henry's law here. The amount of air or gas dissolved in a liquid is directly proportional to partial pressure of the air or gas. So this is the Henry's law. Of course, this has to be applied at constant T. टेम्परेचर चेंज करने से सॉल्युबिलिटी डिक्रीज होता है. सो दिस हैज़ टू बी नोटिस्ड, राइट? सो आपको थोड़ा कॉन्सेप्ट समझ में आ गए. हायर द प्रेशर, हायर इज डिजॉल्व्ड इन ए लिक्विड इज डायरेक्टली प्रोपोर्शनल टू द पार्शियल प्रेशर ऑफ द गैस इन कॉन्टैक्ट विद दिस. सो वी राइट है इक्वेशन, छोटा इक्वेशन भी लिख लेंगे, इसके ऊपर न्यूमेरिकल्स भी पूछेगा और कैसे होता है देख लीजिए. अमाउंट एंड पार्शियल प्रेशर एक ही होता है, देख लीजिए. सो अमाउंट ऑफ गैस डिजॉल्व्ड इन दिस इज डायरेक्टली प्रोपोर्शनल टू पार्शियल प्रेशर ऑफ द गैस. सो अमाउंट वी टॉक अबाउट, अमाउंट कैसे बात करेंगे? अमाउंट तो वी कांट टॉक अबाउट द ग्राम्स, राइट? तो ग्राम्स में बात कर सकते हैं आप, जनरल केस में ग्राम्स में बात कर सकते हैं, लेकिन ग्राम्स के जगह वी यूज़ मोलारिटी यूज़ कर सकते, राइट? या मोलालिटी यूज़ कर सकते, या मोल फ्रैक्शन भी यूज़ कर सकते, मोल फ्रैक्शन भी यूज़ कर सकते. सो द हेनरी हैज़ यूज्ड दिस मोल फ्रैक्शन. So what I'm going to replace here, I'm going to replace the amount by mole fraction of the gas, right? So the mole fraction of the gas dissolved in water is directly proportional to the partial pressure. Partial pressure is directly proportional to mole fraction of the gas. I'll write it clearly. Partial pressure. Partial pressure is applicable to only gases. This is directly proportional to mole fraction. So partial pressure of the gas and mole fraction of gas directly proportional. Partial pressure we denote it by P, mole fraction we denote it by X. P is directly proportional to X. This is known as Henry's law. यहाँ आप प्रोपोर्शनलिटी सिंबल निकाल सकते हो. सो विच इज़ P इक्वल टू विल टेक ए कांस्टेंट KH इंटू X. तो X जनरली वी टॉक अबाउट 2, सो X2 की बात कर रहे हैं. सो दिस इज हेनरीज इक्वेशन. हेनरीज इक्वेशन इज P इक्वल्स टू KH इंटू X2. KH is known as Henry's constant. This is known as Henry's constant, right? So this is Henry's law. आपको एक बार लिख लेना, ये वेरी इंपॉर्टेंट है. इजी क्वेश्चन होता है, बस जस्ट यू नीड टू अंडरस्टैंड द कॉन्सेप्ट हियर. सो ఇట్ వుడ్ బి ఈజీ ఫర్ యూ. హెన్రీస్ లా ఒకసారి రాసుకోండి అమ్మా. 1 minute టైం తీసుకొని ఇది రాసుకోండి, ఈక్వేషన్ రాసేసేయండి. ద అమౌంట్ ఆఫ్ గ్యాస్ డిజాల్వ్డ్ ఇన్ ఎ లిక్విడ్ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు ద పార్షియల్ ప్రెషర్ ఆఫ్ ద ఎయిర్ ఆర్ గ్యాస్ ఎట్ కాన్స్టెంట్ టెంపరేచర్. So P equals to X2 okay, right. So we'll further continue our discussion. So we have got P equals to KH into X2. So this is the Henry's equation. So P is the partial pressure, X2 is the mole fraction of the gas and KH is the Henry's constant. Henry's constant जो है, this Henry's constant is different for different gases. Is different, is not common for everything. Different for different gases. Different gases के लिए ये different होता है, right? These values are given. And can you establish the relation? X2 लिख सकते हो आप. X2 equal to क्या लिखेंगे? Partial pressure by KH. Can you what is the relation between KH and X? ఈ రెండింటి మధ్యలో డిఫరెన్స్ ఏముంది చెప్పండి. డైరెక్టా ఇన్వర్సా? ఆర్ దే డైరెక్ట్లీ కనెక్టెడ్ ఆర్ ఇన్వర్ట్లీ కనెక్టెడ్? సో X2 and KH are inversely proportional to each other, right? Right. What is the meaning here? अगर KH मेरा लो है, X2 कैसे होगा? हाई होगा. X2 is nothing but solubility. The amount of gas dissolved in liquid is the solubility. If KH is high, so that is X2 is low or low solubility. Do you understand this point? आपको KH कम है because the relation is inverse relation. उनका relation inverse है. If KH is maximum, X2 would be minimum, X2 would be highest. If KH is highest, X2 would be lowest होगा, right? So आपको कुछ values दिया जाएगा. From basis of those values, you are asked to calculate or identify the gas with the highest solubility or the gas with the lowest solubility. So these type of questions are generally asked. So right, we will open our NCRT, just will check what is being given there. Henry's constant ఎట్లా ఎక్స్ప్లెయిన్ చేశాడో సరే ఎన్సీఆర్టీ చూస్తే మనకు క్లియర్గా అర్థమవుతుందండి. Right, so this is the general introduction, you can check here. The solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent at specified temperature. It depends upon the nature of the solute and nature of the solvent as well as the temperature and pressure. Let us consider the following factors here. The solubility यहाँ explain किया है, कुछ different cases भी explain किया है. The solubility of solid in a liquid. So this is not about Henry's law, but we will discuss. Every solid does not dissolve in a given liquid. While sodium chloride, sugar dissolve readily in water, naphthalene, anthracene do not dissolve in water because they are unlike solvents. On the other hand, naphthalene, anthracene get dissolved readily in benzene, but sodium chloride, sugar do not dissolve in it. We know that like solutes dissolve in like solvents. Polar solvents, polar solutes get dissolved. Polar, non-polar, they don't mix with each other. It is observed that polar solutes dissolve in polar solvents, makes sense. Non-polar solutes dissolve in non-polar solvents. In general, solute dissolves in a solvent if the intermolecular forces of interactions are similar to like dissolves like. Right? So this is simply formation of the solution. When a solid solute is dissolved in a solvent, the solute dissolves and its concentration increases. The process is known as dissolution. Some solute particles in solution collide with the solid solute particles get separated out of solution. This process is known as crystallization. A stage is reached where two processes occur at the same rate. So this condition is known as the equilibrium condition or dynamic equilibrium condition. Solute plus solvent is solution. So he is discussing about the formation of the solution. And solutions are of three types. At this stage, the concentration of solute solution remains constant under given conditions. If temperature, pressure, similar process is followed when gas is dissolved in solvents. Such a solution in which no more solute can be dissolved at the same temperature and pressure is called as saturated solution. Saturated solution is the one which contains maximum amount of solute dissolved in it at same temperature and pressure. An unsaturated solution is one in which more solute can be dissolved at the same temperature. Solution which is dynamic in equilibrium with undissolved solute and saturated solution contains the maximum amount of solute dissolved in the amount of solvent. Concentrations of solute in such a solution is called as solubility. Effect of temperature, pressure, you have studied it in the Le Chatelier principle lo already manam chadivi unnam. Just we revise it. Solubility of a solid is significantly affected by temperature changes. Consider the equilibrium presented in 1.1 in the first year. This being dynamic equilibrium must follow the Le Chatelier principle. In general, in a nearly saturated solution, the dissolution process is endothermic. Dissolution process is an endothermic process. That means heat is being absorbed. The solubility should increase with raising temperature. If it is exothermic, and the solubility should decrease. The trends are also observed experimentally. Then we have the pressure. Next we will come to the Henry's law. This is our point of topic, solubility of gas in liquid. Many gases dissolve in water. oxygen dissolves in only in small extent in water. It is this dissolved oxygen which sustains all aquatic life. On the other hand, hydrogen chloride is highly soluble in water. The solubility of gases in liquid is greatly affected by pressure and temperature. The pressure and temperature. The solubility of a gas increases with increase in pressure. So this is the Henry's law. The solubility of the gas increases with the increase in pressure. So ఇదంతా ఎక్స్ప్లెయిన్ చేశాడు ఇక్కడ, రైట్. హై ప్రెషర్ ఈజ్ అప్లైడ్ హియర్, ద అమౌంట్ ఆఫ్ గ్యాస్ డిజాల్వ్డ్ ఈజ్ హైయెస్ట్. దీంట్లో చూడండి, దీస్ పార్టికల్స్ ఆర్ గ్యాస్ పార్టికల్స్, లిక్విడ్ పార్టికల్స్. ఓన్లీ హీ ప్లేస్డ్ one piston with the W1 weight, but the weight has been increased, so here is high pressure. In second case, high pressure is used. That's why you can see the more dots dissolved in the water. More dots dissolved in the water. Okay. So Henry was the first to give a quantitative relationship between the pressure and solubility of a gas in a solvent, which is known as Henry's law. The law states that it is applicable at constant temperature. The solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. So this is the Henry's law. The solubility, the amount of gas dissolved, that is what the solubility in a liquid is directly proportional to the partial pressure of the gas present in it. ఇక్కడ హై ప్రెషర్ వేశాడు కాబట్టి ద అమౌంట్ ఆఫ్ గ్యాస్ డిజాల్వ్డ్ ఈజ్ హైయెస్ట్. ఇక్కడ తక్కువ ఉంది కాబట్టి తక్కువ. సో Dalton, a contemporary scientist with the Henry, also concluded independently that the solubility of a gas in a liquid solution is function of its partial pressure. So if we use the mole fraction of a gas for a solution measure of solubility, then it can be said that the mole fraction of a gas in a solution is directly proportional to partial pressure of the gas over it. The most commonly used Henry's law is the partial pressure of a gas in vapor pressure is proportional to mole fraction of the gas. So this is the Henry's equation given here, and this is the graph which is drawn. So mole fraction versus partial pressure. So how do you get this one? It's a straight line without any intersect. ఇక్కడ ఇలాంటిది లేదు కదా. ఇక్కడ y equal to mx plus c లో we don't have mx c, so therefore it is a straight line without any positive slope, without any starting with the origin. This is also important. క్వశ్చన్లో ఒకసారి ఏం అడిగారంటే, ఇక్కడ ఎక్స్ ఇచ్చారమ్మా, ఇక్కడ వై ఇచ్చారు. ఆప్షన్స్లో ఎక్స్ ఏంటి వై ఏంటి అని అడిగారు. సో దిస్ టైప్ ఆఫ్ క్వశ్చన్స్ ఆర్ జనరల్లీ ఆస్క్డ్, రైట్. Experimental results for solubility of HCl gas in cyclohexane at 293 Kelvin. The slope of the line is the Henry's law constant, and that is Kh, right. So this is our right. So ikkada graph kuda entamma, graph kuda manam geesukovali. So graph looks like this one. The x-axis is, this is the mole fraction of HCl. This is partial pressure of HCl on the y-axis, and we got the straight line, right. So straight line because P equal to KH into x2 plus 0 కాబట్టి. So this is in the form of, let us say this is y equal to mx plus c. So ఇక్కడ intersect ఏంటండి 0. On x axis what should be taken? The mole fraction of HCl should be taken, and y axis the partial pressure should be taken. And what is the slope here? The slope of is equals to Henry's constant. The slope is equals to Henry's constant. So this is the Henry's law. ఒకసారి గ్రాఫ్ గీయండి అమ్మా. గ్రాఫ్ ప్లస్ ఈక్వేషన్. నవేడేస్ ఎట్లా ఇస్తున్నారంటే ఈ స్లోప్ ఇస్తున్నారమ్మా క్వశ్చన్లో. స్లోప్ వాల్యూ ఈజ్ గివెన్ లైక్ 2 or 3 or something else, and x2 is given and you are asked to calculate like 1, 2 or 0.1 ऐसा कुछ दे रही, and you asked to calculate the partial pressure. సో ఇక్కడ స్లోప్ అనేది KH అనే విషయం మీకు గుర్తుండాలి. దెన్ ఓన్లీ యూ విల్ డూ ఇట్. సో యూ విల్ గెట్ ద స్ట్రైట్ లైన్ విత్ జీరో ఇంటర్సెక్షన్. ఓకే, చేశారమ్మా? గ్రాఫ్ గీసారా?
What, Angelina? After 9-5 you joined.
Sir, network issue.
Okay. So this is it. So here we will also see few more points should be noticed here. It is obvious from the equation 1.11 that this is the 1.11 equation, that higher the value of KH at given temperature, lower is the solubility of the gas in a liquid. సుషార్గా ఇక్కడ ఇన్వర్స్ రిలేషన్ కనిపిస్తుంది. If your X is highest, KH is lowest. If X is lowest, the KH is highest. Right? So higher the value of KH at given pressure, lower is the partial pressure of the liquid. So we have got a table here in the next page. So this is the table. Right? So table 1.2 gives you values of Henry's law constant for some selected gases. The gases given are helium, nitrogen at two different temperature. Nitrogen is taken at 293 K as well as 303. Oxygen is also taken at two different temperatures, 303, 293. Argon CO2, formaldehyde, methane, vinyl chloride. So these are the KH values given in the per kilo bar, given for kilo bars में दिया हुआ है, right? So ఇక్కడ ఉన్నటువంటి values లో, so out of all these values, So you have to find the maximum and the minimum. Maximum value దేనికి ఉందో చెప్పండి. So all of it, the maximum value looks where? Its maximum value is 144.97, correct hai? అంతేనామా? So 144.97 is the maximum value. What is the minimum value? Minimum value చెప్పండి.
Methane, sir.
మీథేన్ కాదమ్మా, చూడు మళ్ళీ ఇంకోసారి చూడు వాల్యూస్. గ్యాస్ పేరు చెప్పమ్మా. మినిమం వాల్యూ మీథేన్ 0.43 ఉంది, ఇది 34. మినిమం ఏది తక్కువ ఏదమ్మా? 0.43 తక్కువ, ఇంకా అంతకంటే తక్కువ కూడా ఉంది ఒక వాల్యూ. వినైల్ క్లోరైడ్ is 0.6 is bigger than 0.4 కదమ్మా. 0.4 ఎస్ ఫార్మాల్డిహైడ్. ఎందుకు ఫార్మాల్డిహైడ్ చెప్పండి. ఫార్మాల్డిహైడ్లో ఇక్కడ 10⁻⁻5 ఉంది, అవునా? Do you understand this one? So this value is 0.00000183. 1 2 3 4 5, correct hai? This value he has written in terms of 10⁻⁻5. So the highest value is for helium, and this is the minimum, right? And the relation is always inverse relation hai. So partial pressure equal to kh into x kada. Yeah, x equals to partial pressure by kh. So partial pressure of the gas, this x and kh are inversely related. So जिसका ये highest है उसका x या solubility कैसे होगा? लोएस्ट होगा. तो लोएस्ट solubility किसको होना चाहिए? हीलियम को होगा, राइट? सो दिस हैज गॉट द लोएस्ट solubility at 298 Kelvin, right? If kh value is lowest and x value would be कैसे होगा? मैक्सिमम होगा. So x is what? The amount of gas dissolved in the liquid. So therefore formaldehyde's solubility is maximum. Do you understand this one? समझ में आ गया ये? We shall do one thing here. ఇది క్లియర్గా అర్థమైతేనే యూ కెన్ ఆన్సర్ ద క్వశ్చన్. चलो आपको क्या करना है, इसका ऑर्डर बनाना है. यू हैव टू मेक द ऑर्डर ऑफ इट. सेम ऑर्डर आपको बनाना है. एक टेबल बनाएंगे. इस टेबल में आई विल मेक इट एज 2 tables, 2 कॉलम्स रख देता हूँ. राइट. सो सबसे फर्स्ट हाईएस्ट solubility formaldehyde है, राइट? सो formaldehyde structure is like So HCHO is the formaldehyde. HCHO is the formaldehyde which टॉप्स सबसे हाईएस्ट होगा इसका. సెకండ్ ప్లేస్ में कौन आएंगे? तो దీని తర్వాత లోయెస్ట్ ఉన్నది ఎవరు? మీథేన్, రైట్, CH4. దీని తర్వాత హైయెస్ట్ ఉన్నది ఎవరు? వినైల్ క్లోరైడ్. వినైల్ క్లోరైడ్ ఈజ్ CH2 డబల్ బాండ్ CHCl, రైట్. సో ఫోర్త్ వన్ ఎవరు? 0.16 తర్వాత 0.611 తర్వాత యూ హ్యావ్ 1.6. ఫోర్త్ ప్లేస్లో ఎవరున్నారు? CO2, రైట్. సో ఫిఫ్త్ ప్లేస్లో ఎవరు వస్తారు? CO2 కే బాద్ కోన్ ఆయేంగే? చెప్పాలమ్మా, CO2 తర్వాత ఎవరు వస్తారు? We are done with these gases, right? So then we'll go to the highest values. So దీంట్లో లోయెస్ట్ ఏముందమ్మా? ఆక్సిజన్ ఉంది, రైట్. ఆక్సిజన్ ఎట్ వాట్ టెంపరేచర్? 34, రైట్. ఫిఫ్త్ ప్లేస్లో O2 ఎట్ 293. దెన్ కమ్స్ 34 తర్వాత బిగ్గెస్ట్ ఎవరు? ఆర్గాన్ ఎట్ 298. దెన్ కమ్స్, సో దిస్ వన్ ఈజ్ డన్, దిస్ వన్ ఈజ్ డన్. దెన్ 40 తర్వాత ఎవరు రావాలి? 46 రావాలి. దట్ ఈస్ O2 ఎట్ 303 Kelvin temperature. So after this, who comes here? 8th ప్లేస్లో ఎవరు ఉండాలమ్మా? హైడ్రోజన్ గ్యాస్ ఎట్ 293 Kelvin, కరెక్ట్. దిస్ ఈజ్ ద 69. దెన్ విల్ గో టు 76, కరెక్టేనా? 76. సో 9th ప్లేస్లో వీ హ్యావ్ గాట్ నైట్రోజన్ గ్యాస్ ఎట్ what temperature? 293. And in 10th place, nitrogen gas at 303 Kelvin. And on the 11th place, you have got helium at 293 Kelvin. So this is the order of them, how they are being placed, right? So with increasing order, decreasing order రాయడం రావాలి. Then only you will able to understand the concept here. హయ్యర్ ఈజ్ ద, దీంట్లో ఏమీ లేదండి. దీంట్లో మీకు గుర్తుండాల్సింది ఈ ఫార్ములా అంటే P=KH×X. క్వశ్చన్ అడగడం ఈ రెండింటికి అడుగుతాడు అంతే, అక్కడ కన్ఫ్యూజ్ చేస్తాడు అంతే. సో యూ హ్యావ్ టు రైట్ ద వాల్యూ ఆఫ్ KH లైక్ దిస్, దెన్ ఓన్లీ యూ షుడ్ ఏబుల్ టు రైట్ ఇట్. ఇన్వర్స్ రిలేషన్ आपको పతా హోనా चाहिए. ఆప్షన్స్లో క్వశ్చన్ ఎట్లా ఇస్తారంటే చూడండి, క్వశ్చన్ విల్ బి లైక్, ఐ విల్ టేక్ కేర్. క్వశ్చన్ విల్ బి the following gas dissolves maximum at 300 Kelvin temperature. So options will be like this. ఏదొస్తుందమ్మా? వాట్ ఈస్ ద ఆన్సర్ ఫర్ దిస్ క్వశ్చన్? అవి ఇప్పుడే చూశారు కదా. సో యూ హ్యావ్ CO2 ఏ ప్లేస్లో ఉంది చూడండి? 4th ప్లేస్లో ఉంది CO2. హీలియం ఈజ్ ఇన్ ద లాస్ట్ ప్లేస్. నైట్రోజన్ ఈజ్ ఇన్ 9th and 10th place, రైట్. ఆర్గాన్, డూ వీ హ్యావ్ ఆర్గాన్? ఆర్గాన్ ఈజ్ ఎట్ 6th place. వాట్ ఈస్ ద ఆన్సర్? CO2 ఈజ్ ద వన్, రైట్. అండ్ వన్ మోర్ కాన్సెప్ట్ ఐ వుడ్ లైక్ టు టెల్ యూ హియర్, రైట్. రెగ్యులర్ gases solubility always minimum होता है, always minimum होता है. There are some irregular gases जनरली ये लिक्विड फॉर्म में होता है, लेकिन easily they can be converted into gases. तो इसका solubility, सॉरी मैंने उल्टा लिख दिया है, या इसका मिनिमम है, इसका कैसे होगा? मैक्सिमम होगा, करेक्ट ही है. సో మ్యాక్సిమం होगा. రెగ్యులర్ గ్యాసెస్ అంటే ఏవి గుర్తు రావాలంటే మీకు అట్మాస్ఫియర్, ఇప్పుడు కరెంట్ సిచ్యువేషన్లో అట్మాస్ఫియర్ ఎయిర్లో ఉన్నటువంటి గ్యాసెస్ ఏంటి చెప్పండి అమ్మా? నైట్రోజన్ ఈజ్ ప్రజెంట్ అరౌండ్ 78%. ఇట్స్ ఎ రెగ్యులర్ గ్యాస్. Oxygen is present around 20%. It is a regular gas. All halogens are, sorry, halogens are noble gases. All noble gases are regular gases. Hydrogen is a regular gas. Oxygen is a regular gas. Hydrogen, oxygen, these are the regular gases. But irregular gases ఏంటంటే HCl. HCl actually it's a liquid. But if you heat it, it will convert into a gaseous form. Right? Ammonia is a liquid. But थोड़ा बहुत गर्म कर दिया है, it converts to ammonia gas. Right? So regular gases को liquid में convert करना possible under normal condition लो साध्यम कादे. It's not possible for us to convert these gases into liquids at normal conditions. But these irregular gases, CO2 is a gas but easily converted into liquid. As compared to these ones, they are easily converted into liquid. H2O is a liquid but can be converted into H2O vapors at 100 degrees Celsius. So this is in the gaseous form. So these gases are irregular gases. Right? Irregular gases can be, they have maximum solubility in it. So ఇక్కడ మీరు చూస్తే కూడా అదే కనిపిస్తుంది చూడండి. ఫార్మాల్డిహైడ్ ఈజ్ ఇలా రెగ్యులర్ గ్యాసే చూడండి లాస్ట్ ప్లేస్లో ఉంటాయి. హీలియం ఈజ్ ఎ రెగ్యులర్ గ్యాస్, నైట్రోజన్ ఈజ్ ఎ రెగ్యులర్ గ్యాస్, హైడ్రోజన్ ఈజ్ ఎ రెగ్యులర్ గ్యాస్, ఆక్సిజన్ ఈజ్ ఎ రెగ్యులర్ గ్యాస్, ఆర్గాన్ ఈజ్ ఎ రెగ్యులర్ గ్యాస్. అండ్ దిస్ CO2 ఈజ్ ఎ గ్యాస్ బట్ CO2 can be converted easily. Vinyl chloride, formaldehyde, methane are also gases but they are easily convertible gases होता है. Right? So यहाँ एक critical temperature అని కూడా వస్తుంది. The gases with the highest critical temperature are easy to convert into liquid state. So their solubility is highest ఉంటుంది. So critical temperature మనకి ఇప్పుడు సిలబస్లో లేదు, we don't discuss that, but you should remember that. What I mean to say here, if question is asked, ఈ ఫస్ట్ 3 గుర్తుంటే సరిపోద్దండి. ఫస్ట్ 4 గుర్తుంచుకుంటే సరిపోద్ది. యూ హ్యావ్ టు రిమెంబర్. సో యూ డోంట్ హ్యావ్ టు రిమెంబర్ దీస్ వాల్యూస్. ఈ ఫస్ట్ గ్యాసెస్ గుర్తుంచుకోవాలి. అట్మాస్ఫియర్లో ఆక్సిజన్, ఆర్గాన్, O2, హైడ్రోజన్, నైట్రోజన్, హీలియం గ్యాసెస్ ఆర్ ప్రజెంట్ ఇన్ అట్మాస్ఫియర్. మోర్ దాన్ 1% ఉంటాయండి ఇవన్నీ కలిపి. ఇవన్నీ ఒక్కొక్కటి 1% కంటే ఎక్కువనే ఉంటాయి. బట్ ఫార్మాల్డిహైడ్ ఈజ్ వెరీ లెస్, CH4 ఈజ్ వెరీ లెస్, వినైల్ క్లోరైడ్ ఈజ్ వెరీ లెస్, CO2 ఈజ్ ఆల్సో వెరీ లెస్ దాన్ 1% ఉంటుంది CO2 కూడా. ఇఫ్ ఇట్ ఈజ్ మోర్ దాన్ 1%, సో పీపుల్ విల్ సఫోకేట్ ఆర్ దే రన్ అవుట్ ఆఫ్ బ్రీత్ ఫర్ ఆక్సిజన్. ఓకే, సో దిస్ ఈజ్ ద అప్లికేషన్స్ ఆఫ్ వినైల్ క్లోరైడ్. రైట్? సో దీనిపైన క్వశ్చన్ వేస్తే డైరెక్ట్ క్వశ్చన్ 4 ఆప్షన్లో మ్యాక్సిమం సాల్యుబిలిటీ ఏది ఉంటుంది, మినిమం ఏది ఉంటుంది ఇస్తుంది. సో ద వాల్యూస్ ఆఫ్ హెన్రీస్ కాన్స్టెంట్ సమ్ సెలెక్టెడ్ గ్యాసెస్ ఆర్ గివెన్. రైట్? ఇక్కడ వీ షుడ్ అండర్స్టాండ్ వన్ మోర్ పాయింట్ ఆల్సో. సో ద పాయింట్ ఈజ్ nitrogen solubility is given 2 times. Nitrogen at 293 is 76. Nitrogen at 303 is 88. చెప్పండమ్మా ఏమైంది ఇక్కడ? టెంపరేచర్ ఇంక్రీజ్ అయితే KH వాల్యూ ఇంక్రీజ్ అయింది, అంతేనా? KH వాల్యూ ఇంక్రీజెస్ విత్ ద టెంపరేచర్. వాట్ హ్యాపెన్స్ టు సాల్యుబిలిటీ? చెప్పండి, సాల్యుబిలిటీ ఇంక్రీజెస్ ఆర్ డిక్రీజెస్? టెంపరేచర్ ఆర్ సాల్యుబిలిటీ రిలేషన్ చెప్పాలమ్మా, దీన్ని బట్టి అర్థం కావాలి ఇప్పుడే. ఈజీ టు ప్రిడిక్ట్. ఇఫ్ టెంపరేచర్ ఈజ్ లోయెస్ట్, KH ఈజ్ లోయెస్ట్. ఇఫ్ KH ఈజ్ లోయెస్ట్, సాల్యుబిలిటీ ఈజ్ హైయెస్ట్. ఇఫ్ టెంపరేచర్ ఈజ్ హైయెస్ట్, KH value is higher. If KH value is higher, the solubility will be lower. Even you can see with the oxygen also. At 293, the KH is 34. At 303, how much is it? 46. As temperature increased, what happened here? The KH value increased. KH value increase हो गया तो solubility क्या हो गया? Decrease हुआ है. Isn't it? That's why he gave two gases at different temperatures. Right? So what can we say that? What can we say here? The solubility is inversely proportional to temperature. Inversely proportional to temperature. Lower the temperature, higher is the solubility. Higher the temperature, lower is the solubility. इसका एक application असता चूडंडी. We have a aquarium. ఇందులో రెండు aquariums ఉన్నాయి. Assume that one is at 25 degrees Celsius, another is at 35 degrees Celsius. Right? So you have fish in it. ఇందులో fish ఉంది, ఇందులో కూడా fish ఉంది. Right? So in which case the fish will be more comfortable? చెప్పండి అమ్మా, ఆలోచించి చెప్పాలి కొంచెం. ఇందులో ఫిష్ కంఫర్టబుల్గా ఉంటుందా, ఇందులో ఫిష్ కంఫర్టబుల్గా ఉంటుందా? ఎవరు చెప్తారు?
25 degrees Celsius.
ఎస్, 25 degrees Celsiusలో కంఫర్టబుల్ ఉంటుంది. వై? బికాస్ టెంపరేచర్ ఈజ్ లో. Temperature is low, so the dissolved oxygen is more. So it can breathe easily. Easy breathing is possible. Here the temperature is high, the solubility of oxygen is low. So oxygen कम होगा ना उसको, तो इसको ज़िंदगी जीना बहुत मुश्किल हो जाएगा. Right? Do you understand the concept? If you increase the temperature, what happens? The dissolved oxygen undergoes undissolution. It will be going outside this one. So the amount of oxygen dissolved becomes lesser and lesser, and the aquatic life becomes tougher and tougher. Aquatic life becomes tougher and tougher. Right? So here are some applications of Henry's law are given. 4-5 are given, just we'll go through it. Henry's law finds several applications in industries and explains some biological phenomena. Notable among these are: to increase the solubility of CO2 in soft drinks and soda water, the bottle is sealed under high pressure. High pressure, amount of salt dissolved is higher. Scuba divers must cope with high concentrations of dissolved oxygen, breathing air at high pressure and underwater. Increased pressure increases solubility of atmospheric gases in blood. So when scuba divers enter into the deep sea, they enter into the sea to the deepest level. So when they go deeper, the pressure increases. If the pressure increases, the atmospheric gases dissolve in blood for more extent. When divers come towards the surface, the pressure gradually decreases and the dissolved gases lead to formation of bubbles of nitrogen in the blood. So this blocks the capillary and creates the medical conditions known as bends, which are painful and dangerous to life. So to avoid bends as well as the toxic effects of high concentrations of nitrogen in the blood, the tanks used by scuba divers are filled with air diluted with the helium and nitrogen and oxygen in this composition. Next one, high altitude, the partial pressure of oxygen is less than at the ground level. ऊपर पहाड़ में कैसे होगा? ऑक्सीजन लेवल बहुत लो होता है. This leads to low concentration of oxygen in the blood and tissues. People living high altitude and climbers So, blood oxygen causes climbers to become weak and unable to think clearly, symptoms of conditions known as anoxia. So, this is another condition. So, you don't work 100% when you are walking in a hill because the oxygen, the pressure is low. So, the oxygen pressure is low. So, the dissolved oxygen in the blood will be lowest होता है. Next, effect of temperature is mentioned here. The solubility of the gas in a liquid decreases with raising temperature, right? So, decreases with raising temperature. When dissolved, the gas molecules present in liquid phase and process of dissolution can be considered similar to condensation, and heat is evolved in this process. We have learnt in this last dissolved process involved dynamic equilibrium, thus must be Le Chatelier principle. So, this is our this process, Henry's law constant. So, previously asked questions are, one is of course JE question, definition, graph, these questions are asked. Definition, graph, and most of the time questions are asked from the KH values. You will be given like A, B, C, D gases. इसका KH values will be given like 1, 10, 101, 55. So किसका solubility highest है, किसका solubility lowest है, ऐसे questions पूछ रहे हैं. तो आपको इसके ऊपर भी ध्यान रखना है. So ये थोड़ा numericals we will solve it in the next class. Okay. Okay, sir. Balda, sir. See you next time in the evening.